This is a typical breaker panel that you're going to see on most of the boats out there today. As you can see here, there's white and red breakers. Basically on the left-hand side, you've got your white breakers, which are your 110 service, your shore power, if you will, coming in, or your 110 from your generator. The red breakers are your 12-volt system, which is coming from your batteries. We've also got some gauges on here that you can see. The 4 on the left there, the top 2 on the left are looking at AC voltage, again coming from the shore from your generator. The 2 right below them are tracking the AC amps, or the current draw, how much current you're drawing of that voltage that you're bringing in, either from your generator or from your shore power. The 2 on the right, one on top of the other, those are DC gauges. They're showing you the DC voltage coming in on the top there from your batteries, and below it is the DC amp draw, or the current that you're drawing from your batteries from your DC side. I always typically, when I leave the boat, depending on what time of year it is, in the summertime, we tend to leave it more like the house, really. I mean, we'll leave most of the 110 breakers on. Sometimes if you're prone to a lot of electric storms, it might behoove you to kill as many of those as you can, or leave them in the off position when you leave. So if you do get any spikes from lightning or anything like that, many times marinas are not the most well-grounded structures, and you can get surges coming through your electrical system at your slip. If your breakers are off, you're going to be a little more protected from that. Typically around here we don't have those issues, so we basically leave the majority of those breakers on, and that's basically just for we leave the air conditioning or heating on most of the time. We're in the Washington, D.C., Virginia area, so there's maybe a couple months a year when we have to winterize, but other than that, the ship systems for heating and air conditioning pretty much take care of things. Things like that you just don't need while you're not here. I'll turn the water heater off because that draws a lot of current. I'll turn maybe the microwave off. Those breakers will be off. Big stove breakers off. But I'll usually leave port and starboard systems on, and the AC converter on, which is constantly charging the batteries if they need it. It also turns itself off if the batteries become fully charged and reach what they call terminal voltage on the converter, and the converter turns itself off so it doesn't cook the batteries. But if you do leave your battery charger on, it is important to check them for electrolytes, for fluid, for water. We usually do that about once a month. Sometimes it goes longer than that. It really shouldn't, but we have 7 batteries on this boat, and typically in a month to 2 month period, we might put 2 gallons of water in 7 batteries. So now we use our boat a lot, and we have some pretty extensive stereo equipment on here and some other big 12-volt draws. So our batteries are working a lot. They're constantly discharging and being recharged. So it's definitely important to keep the water up in the batteries. On the DC side now, we pretty much turn everything off when we leave. DC lights, the water pumps, domestic water pumps, I turn those off just in case you've got, you spring a leak or something, and all of a sudden your pumps are running and could potentially run dry or burn up. If they're off, you just don't have to worry about that. Same thing with the head system. If you've got some sort of we have a vacuum flush head on this boat. If you were to experience some kind of a vacuum leak or something that pops up while you're not here, you could end up with a situation where your vacuum pump for your toilet system is running pretty much constantly. So again, not that we've ever had that happen, but it can happen. I know it's happened to other boats. If those breakers are off, you just don't have to worry about any of that. So basically the only thing we leave on, we leave the boat on the 12-volt side, is our refrigerator breaker. Our refrigerator typically works on the 110 side under the galley system breaker, but in the event of power failure, obviously we'd lose all that, so then the refrigerator and freezer kicks in on the 12-volt side. Our refrigerator freezer is 110 and 12-volt. So conversely, if we're out in the water at an anchorage or something, and we're not plugged into power, obviously, and maybe we don't want to run the generator, we're running off the battery for our fridge and our freezer, which is pretty handy. The other stuff in here, you've got your ignition breakers in here, ignition switches, top, middle of the panel there. You've got those 3 buttons together. There's a generator, start and stop switches, and preheat switches, and blower switches. And then above the 4 gauges, the 4 white gauges on the left there, you've got 2 big transfer switches that you can see. Those are the switches that you throw to transfer from shore power to generator. Obviously, if we're on the shore, we've got the shore breakers on and the generator breakers off. Vice versa, if we're out and we're running the generator and we're unplugged from the shore, our shore is off and our generator is on. Obviously, you can't have both at the same time, or else you'd blow something, and that's why we have a transfer switch to make sure that one's off before the other one comes on. We also have a water level switch in here, which checks the water level. We have the sewage system, toilet system, pumps, and the equipment that runs with that. And then we also, finally, we have a battery test, so we can test our voltage, and that's the switch above the 2 white meters or gauges on the right there. And basically, we can check each of our banks independently, port or starboard, and see what kind of voltage we've got, and keep track of what our batteries are doing. Obviously, if you let your batteries go down, it takes an enormous amount of time, especially if you've got a lot of them, to get them back up again. So, and it can take a couple of days to charge, several batteries up. This particular boat's got a 60 amp charger on it, which really does pretty well. It actually, when you turn it on, it bumps all the batteries with 14.4 volts and gives them a good surge for a certain period of time. I can't remember what it is. And then it cuts back and kind of stages back in its voltage and its charge, its amperage and its charge, until it's got the batteries fully charged, and then it steps back all the way to 0. Those particular converters and chargers are a little more expensive, but I think they're well worth it. They won't cook your batteries. They'll make sure your 12-volt system stays where it's supposed to be, and nothing can be more frustrating than having a dead battery when you want to start it, or you're out there and you've been playing music, or your refrigerator's been running, or whatever else you've been doing with your 12-volt side, and all of a sudden you've got a dead battery and you can't get back in. So keeping your batteries up and charged during the week when you're not here boating on the weekends or whatever is pretty important, and having those systems automated and working in a manner that does that is a good thing to do. I think that's basically it. Pretty standard setup. You guys have probably seen this before. That's it.